Question 7 is another question about coordinate systems. This time it's about parabolas. We are given the general point, and we have to find that the normal to C at P has this equation over here. So at first we have to find dy by dx. Dy by dx will be dy by dt times dt by dx, or simply put dy by dt divided by dx by dt. Now we know that x, we're given that x is 1 by 3t square and y is 2 by 3t. So dx by dt would be 2 by 3t, dy by dt would be 2 by 3. So we'll have dy by dt, which is 2 by 3, divided by dx by dt, which is 2 by 3t. We'll basically get 1 by t. This is the gradient to the tangent. Gradient of tangent. The gradient of the tangent multiplied by the gradient of the normal would be minus 1 because they are perpendicular to each other. So 1 by t times m normal is minus 1. So m normal, or the gradient of the normal, is minus 1 divided by 1 by t, which is minus t. Therefore now the equation of the normal, y minus y1 equals to m normal x minus x1. y1 is 2 by 3t. The gradient is minus t, and x1 is 1 by 3t square. So y minus 2 by 3t would be minus tx plus 1 by 3t cube. Now we have to show that 3tx plus 3y equals to t cube plus 2t. There are no fractions over here, so we can multiply both sides with 3 to get rid of the 3's at the bottom. We'll have 3y minus 2t equals to minus 3tx plus t cube. We have y and x on the left and all the t's on the right in the show. So we'll take this minus 3tx to the left, so 3tx plus 3y, and we'll take this minus 2t to the right, so we'll have t cube plus 2t. This is what we had to show, and we're done with this. Now moving on to part B, we are given that t is 9 and that the normal to C at the point P meets the curve again at point Q. The value of t is 9, so 3 times 9x plus 3y is 9 cube plus 2 times 9, so 9 cube plus 18. If we make y the subject over here, we'll get 3y equals to minus 27x plus 747. If we divide both sides with 3, we'll get minus 9x plus 249. Now there are two approaches to deal with this. For this graph we have found, for this equation or this normal, to cut the parabola again. So if we visualize this is the parabola, this is the tangent, so this would be the normal. This goes and cuts the parabola again at this point Q, and we have to find the exact coordinates of this point. Now one thing we could do is, we are given the equation of the parabola, which is y square equals to 4 by 3x, y square equals to 4 by 3x. So we can take x as the subject, so x would be 3 by 4 y square. We can put that in here. We can write that x equals to x. So the x for the parabola will be the value of x for the normal, for them to intersect. Again, we'll have y equals to minus 9 times 3 by 4 y square plus 249. Usually we do y equals to y, but in this case, if I wanted to make y the subject, I'll have root over 4 by 3x. I don't want to work with square roots over here. It's easier to work with this. I'll have y equals to minus 27 by 4y square plus 249. Taking everything to the left, I'll have 27 by 4y square plus y minus 249 equals to 0. If I solve this quadratic, I'd y minus 6 and 27y plus 166. So y is 6 and y is minus 166 by 27. Now the given value of t was 9. If we put the values of 9 here, I'll get 1 by 3 into 9 square, comma 2 by 3 times 9, which is 1 by 3 times 27, comma 6. So the value of y equals to 6 is this point over here. This value is y equals to 6. So for q, the value of y would be minus 166 by 27. So we'll ignore this and work with this. X is 3 by 4 y square, so we'll find x. X would be 6889 divided by 243. So that's the coordinates of q. Q is 6889 by 243, comma minus 166 by 27.